is Kate Keenan, and today we will be describing motion in one dimension. First, we are going to describe motion in terms of displacement. Displacement is the change in your start to finish position. Note, it is not, and I repeat, not, distance traveled. We measure it in coordinate systems. For example, if a biker bikes for 20 miles, then turns back 20 miles, it ends up where he has started. The displacement would be 0. The formula is the change of x. It is x's final position minus the initial position. Velocity also describes motion. Velocity measures how fast something moves from one point to another. You can find it in problems by finding the displacement and then dividing it by the time. For example, in a track meet, if Nancy runs 400 meters in 70 seconds, the average velocity would be 5.7 meters per second. Because you divide 400 meters by 70 when you follow the formula. Velocity, unlike speed, also takes direction into the motion. When being graphed, velocity is the slope of the line because of the change of x over the change of time. In a position time graph, when the line is parallel to the x-axis, the object is at rest. If there is a constant velocity, there will be a steady slope. When there is a change in the velocity, either speeding up or slowing down, acceleration measures it. It is calculated by dividing the change in velocity by the change in time. This is measured by meters per second squared. For example, our car slows from 7 meters per second to 0 meters per second in 3 seconds. To find the average velocity, you subtract 0 minus 7 to get negative 7 meters per second. Then you divide it by 3 seconds to get negative 2.3 meters per second squared. When velocity is constant, the acceleration is 0. When the car picks up speed, the velocity increases in magnitude. Therefore, the acceleration is positive because the final velocity is greater than the initial velocity. There are 5 big kinematic equations that can describe motion in detail. These are used when acceleration is constant. The first equation is missing the variable x. The second equation is missing the final velocity. The third equation is missing time. The fourth equation is missing initial velocity. And the fifth equation is missing acceleration. The variables you are missing are the ones that you don't necessarily care about in the problem, so that leads you to choose the right equation to solve it. Lastly, free fall describes motion by only the force of gravity. The 2 most important things of this is that it does not encounter a resistance, and all free-falling objects go downward at a rate of 9.8 meters per second squared. And now for physics in the news. In the summer, NASA had the Mars rover Curiosity have a successful landing on Mars. It had to follow all laws of physics to be successful. It had to hold a constant velocity to Mars in order to properly land. Also, it had to use acceleration to slow down in order to land on Mars.